Um, um, to begin with, this is a quick outline of my talk. I'll start with some pressing questions, and then I will, before I get into the what, why, how, and how we can become the leader, let me, I'll try to explain the ecosystem and the demand and supply equations in the Indian context. One thing we told the government few years back, that the decision should not be emotional. The decision has to be based on what our ecosystem can digest and can support, and how we further build the ecosystem to digest and support subsequent things. Subsequently, I'll talk about what kind of fabs we should be investing in. For example, there are different strategies for different kind of fabs. Then I will briefly touch base on why we missed the bus, in the interest of highlighting how we can actually catch the bus in future and lead in future. And then I'll briefly touch base on the proposal that we made some time back, which in some sense also help the India semiconductor mission. I'll talk about the semiconductor mission, and then towards the end I'll talk about the gaps which are required to be addressed and the opportunities that we have, and how we can, by filling these gaps, bridging these gaps, can become a leader. So the very pressing question that we have, and I think pretty much everyone who is associated with the semiconductor in one or the other way, ask this question to others, ourselves, and other stakeholders, is can India lead the semiconductor nano manufacturing race? Or in fact, the better question to ask before getting into the leadership is, can India get into semiconductor fab and nano manufacturing race? We are getting into the manufacturing, but getting into race is as a different aspect. And also, then in future, can we become a leader in this field? And if the answer is yes, I mean, I would say the emotional answer is yes, then the logical question will be how. Let's understand, I mean, this is for the audience, students who possibly are just getting into semiconductor, and they would also like to know the strategic importance of semiconductors. It's important to understand why semiconductors are important. This is a slide which I always use in my class, starting with, for example, one of the first IBM calculators, way back in 60s, which was in terms of computational capability, very, I would say, basic. But in terms of size, it was possibly the size of my office. Now, on the other hand, you see, one of those laptops which were less than a kilogram in size. In terms of compute capability, this is significant. You can even run very complex calculations and simulations on this. But in terms of size, this is less than a kilogram. And that kind of technological evolution happened, because of the semiconductor evolution. So anything that we see around us is actually because of the semiconductor evolution. But it's not just the semiconductor evolution. If you think of the larger ecosystem, I mean, the larger ecosystem, the semiconductor industry would be $400 to $500 billion today, but that impacts a larger $2 trillion industry, electronics industry. But not only that, it impacts many other industries as well, other than electronics and computers. For example, the industrial sector, the motor vehicle, the transport, automobile, and other strategic sectors as well. Right? And this global impact is much bigger than the $500 billion semiconductor industry I was talking about. And also, it sets the foundation for future. For example, the semiconductor is the base for the upcoming quantum technologies, or any other upcoming solid state device or solid state physics based technologies, right? So it also sets the foundation for future. So the question now is that what are the challenges for India? And to understand the challenge, let's first get into the ecosystem and try to understand the demand supply equations. And I try to explain this with following. For example, what you have on one side, you have these design houses, right? So these are basically, for example, when we say that so and so companies are there in Bangalore, right? So these are basically design houses. What they do, they design chips, right? Then you have fabs. These fabs at present don't exist in our country. Um, then we have the system developers, and then we have the market, and also we have these products. They can be different kind of products. They can be power SoC analog automotive products, and then they can be discrete products. So now what happens is that these design houses, for example, all these multinational companies in Bangalore, they will basically tape out their designs, and these designs will go to fab. The chips will come back, and these chips will basically be delivered to a system developer, right? The system developer could be, for example, Apple, Samsung, who is getting these chips developed from many other sources and integrating into their larger system. It can also be any handheld manufacturer. It can also be a CPU manufacturer and whatnot, and then that goes to market, right? The other source or the other channel for the market is that you have these IC products which directly touch to market. So these are basically done by the companies which are, for example, in the automotive or power SoC sector, or discrete companies where you don't have a design house. They design the product, they get it fabbed. Either they will have their own fabs or they will get it fabbed elsewhere, and then it can go to a system developer. It can also go to a market. So basically, you have two kind of products. One set of products where the demand comes from the system developer, and the design house will do the tape out. They have set fabs. The chip goes to system developer, and system developer sells in the market the final system. Those chips are not sold in the market directly. But then you have other type of products where basically the chips can be sold directly to the market and can also be sold directly to the system developer, right? Now, if you think in this way, then if a fab is there, even if there's a local fab, the demand, the loading on this local fab will depend on whether this design house can fab on this local fab. And if they have set locations where they're fabbing, then it becomes difficult for the local fab to attract these local design houses to get the fab done locally. Let me explain this further. So if you divide this into different kind of industries and ask this question, who would tape out the chips? Who would load these fabs? So you have these electronics industries, for example, Samsung and Apple's of the world. Would they tape out? The answer actually at present is that they buy well-established commercially available chips, which are custom made. So, for example, Samsung or Apple will give order to different design players, and these design players will design the chip, get it fabbed at standard locations like TSMC, and supply to Apple and Samsungs of the world, right? So then they are not going to load in the present scenario. That has to change in future. The second is startups and Indian design houses. They are always looking for cost effectiveness. So if the local fabs can offer them cost effectiveness, then they will of course load the local fabs. Otherwise, they will always go to places where they have already established process. Then we have existing MNCs or IP developers. For example, the Intel or TI or Samsung design centers in Bangalore. Again, they have their set processes. If they have established their process and their design and the technology and it's qualified in certain fabs, for example, in TSMC or other places elsewhere, then for them changing their fab location is going to be very difficult to begin with. Again, that has to change, right? Now, let's also see what kind of chips. So if you look into the digital or processor market, this is where, say, for example, Apple, for example, Intels of the world, they will design their own processor, they will get their own processors fabbed, and they will sell directly in the market. So basically, this is difficult to beat. You have big fishes like Intel. Then you have custom SoCs. You have custom SoCs where big players like Apple or Samsung, which will already have tie-ups with fabs like TSMC because of the volume requirement. They will not go to a small fab or a fab which cannot cater to their volume requirements. They will go to a fab like TSMC, which can actually cater to their volume requirement at their timelines, right? So again, this is difficult to catch or beat. But you have other sector which is analog, the power SoC, automotive, discrete. These are sectors which basically you can sell the component, you can sell the chips directly in the market. You can cater to small players, right? So this is certainly possible to develop dedicated products. And so you can cater to small players, startups can also pitch in, and this is something easy or low hanging fruit to get in. Now let's go back to this picture I had presented. So now you understand that on one side there's supply, and this supply is a little complex in terms of the way the design happens, the fab happens, and how it reaches to the market. Where on the other hand you have demand, which I presented the previous slide, right? And this demand is also a little complex. So just increasing the demand will not increase the supply, and just increasing the supply will not increase the demand. So there's a complex equation between supply and demand, right? And so far, people were only talking about supply. The question was about the demand, and how do we address this demand equation? How do we fix that demand equation? How do we increase the local demand? If there's local manufacturing, how do we load these fabs if there's local manufacturing? So now, because of this complexity, I came up with these suggestions that what kind of fab the country has to invest in and what timelines. So, for example, there will always be a fascination for advanced technology nodes like 2 nanometer to 40 nanometer, but the fact is that these are extremely expensive. The scope is very limited. For example, at present, mostly limited to the digital or the processor or high compute kind of market, right? And at present, there are no takers in India, right? And also, the fact is that no one gives this particular technology. This is extremely restricted, and typically, the governments will also restrict to let the technology go out of their headquarters. The next one is 28 nanometer. This is kind of a sweet spot, or maybe at the verge of the sweet spot, but this is also expensive. Again, at current scenarios, no one gives the technology, and the demand is kind of limited to big players and MNCs who are already hooked up to companies like TSMCs of the world. So if you want to get into 28 nanometer, you have to really create a local demand so that those kind of fabs can be loaded. Those people who are going to TSMCs of the world can come to this local fab. 40 nanometer, it's a very limited process. It's just digital, not enough demand worldwide. So it's very difficult to meet ROI. 65 nanometer to 130 nanometer, mostly BCD process. This is where you can cater to analog, power SoC, automotive, discrete kind of products. This is very easy to create demand. The demand already exists. You can directly reach out to the system developers. They anyway buy off the shelf components. They anyway buy directly from the market. So you can directly supply to the market as well as to these players who are into some of these sectors. Um, Now, you also have different routes. For example, one can invest in gallium nitride fabs, silicon carbide fabs, silicon discrete fabs. This alone is more than $20 billion market. There's a very big volume requirement in the country because of the EV and the automotive push and the kind of, the number of or the population that we have in the country, because here the demand is just proportional to the population in the country, right? And this is an easier technology. There are a lot of people who are willing to give technology. You also have a lot of expertise available in the country. This is something where India can pitch in, start setting a fab and have a further upgradation and technology upgradation through the local support. Now, the last aspect is the R&D fabs for future emerging technologies. Now, these are the areas, for example, 2D and quantum. These are the areas where, if we jump the roadmap and develop our own IPs upfront, right? These are the areas where we can certainly build leadership in future. I'll talk about this a little later. Now, what has to be kept in mind? One has to maximize the number of takers for least investment and balancing both demand and supply. The bottom line here is that one has to really balance both demand and supply and create an ecosystem, to increase the demand, to cater to the kind of supply we are creating in our country. So now the question is, if somebody asks me which fab we should buy or invest in and when, here is my response. I would say that fabs resulting directly into products to market like GaN, silicon carbide, silicon discrete. This we can build as soon as possible using licensed technologies while having strong ties with indigenous efforts for further upgradation. I mean, you can't live with just licensed technologies. These technologies, semiconductor technologies, improve, or must improve with time. And you can't be relying on somebody to give you technology or license you technology all the time. So in this case, for example, you start with licensing technology and then further upgrade it based on the local or the indigenous efforts which are already going on, right? And for that to grow, one has to also promote parallel local electronics development. Now, the second thing is, fabs like 65 nanometer, 90 nanometer, 130 nanometer BCD. These are all done and dusted technologies. I mean, there's no R&D left in these technologies. And these are the technologies which are today catering to analog, power SoC, automotive, discrete products. And there's almost $200 billion market worldwide. right? Including the analog, automotive, power SoCs, and whatnot, including silicon discrete, right? And if we can cater to this immediately, and this can be catered directly, as you can supply directly to the market and directly to system manufacturers, right? This is something where the volume or the fab loading will not be a problem. So this is something one can buy immediately. One doesn't need to worry about upgradations in future, and this has very low obsolescence rate. So basically, once we have the technology, the fabs can run and supply for another 10, 15 years. Now, the next one are 28 nanometer and the even lower technology nodes. For 28 nanometer, one has to parallelly create local demand for promoting electronics development, and use this local demand to basically load a 28 nanometer kind of a fab in our country. So one has to be careful about the timelines. In this case, the demand has to be created, and parallelly the ecosystem or the setup need to be created for 28 nanometer fab. 2 to 14 nanometer is a long shot. So one need strategies before buying an established line technology. At this stage, nobody is going to give us this kind of technology. So we have to have the right strategy and the timelines in mind. At the same time, the country need to invest heavily on the R&D in sub 5 nanometer nodes, because this requires serious knowledge base, know-how, and manpower pool, and that is needed, and that is kind of must for running a fab like advanced nodes such as 14 and below. And the last aspect is the R&D fabs on upcoming technologies. So upcoming technologies means is still there a lot of scope for one to build IPs, one to build own technologies. And this is something where the country has to invest as soon as possible. One should build multiple R&D fabs or pilot lines. These should be dedicated lines which should allow indigenous technology development, indigenous IP creation, and then use these IPs and technologies which are indigenously done to scale up tomorrow and lead in some of these areas. So some of these areas which are where there's a lot of scope for development and creating your own IPs are such as 2D and quantum, right? But the mindset needed is one has to jump the roadmap if you want to take the lead in the future. Now, let me talk about why we missed the bus, what has to be done. I'll give a case study on the 2D semiconductors. So, I mean, we all ask this question, why we missed the bus, right? There were efforts in the past, but the missing part was the investment on R&D. So while we started, if you remember, we started silicon manufacturing long before Taiwan, but we did not invest on R&D at that stage. We were only focused on manufacturing, and that led to this shortfall. I mean, the R&D has to go hand in hand with manufacturing, because you can license the technology, you can start manufacturing, but then the semiconductor is a technology which requires upgradation, from time to time. One has to jump from one node to the other node. One has to improve the technologies that you are running in your fabs, and for that you need to have local R&D investment. Right, so government has to seriously invest in creating a vibrant R&D ecosystem on various things. It can be center of excellences on materials. We don't have a lot of material growth expertise and capabilities in the country and facilities in the country. We need a lot of R&D fabs in next generation process, which can be 2D materials, memories, gallium nitride, flexible, whatnot, quantum. Right. We also need prototyping fabs, pilot lines, right, to support startups. And we also need research consortiums. So the suggestion that we had given some time back, that the government should invest close to $1 billion on creating a vibrant R&D ecosystem, which should actually feed into the manufacturing requirement going forward. I'll give one example of the 2D semiconductor, which is a next generation technology in which India can become a leader tomorrow. If you look into and compare silicon with 2D, in silicon, the world has done pretty much everything possible. The opportunities to gain technological superiority are missing. I mean, we can become another manufacturer, but we will not be a technology leader if it is silicon or conventional technologies. Also, the fact is that getting access to the bleeding edge nodes is going to be very difficult, because this is often restricted by their respective governments, right? So, while we are embarking on becoming a leading manufacturing hub, the question is, how do we become a leader, without homegrown technology? And that's where the 2D semiconductor comes into picture, because it can not only replace, but augment silicon, right? And it can do much more than what silicon can do. And the options for beyond silicon nodes, is basically with 2D semiconductor. This is at present the most promising option for beyond semiconductor or beyond silicon nodes, right? So while it's emerging, the fact is that we are not too behind. I mean, we can still make a lead. We can still develop a leadership in this area. We have a scope to lead, and if we go aggressive, we can. We have to start early. If we go aggressive, and that's the way forward to develop a leadership, right? So the fact is that today the world will work with us because more or less everyone is on equal footing. Everyone is trying to develop their own IPs, right? So everyone wants to learn from each other. But if you delay, and once others have developed technological superiority, right, we are going to lose this opportunity to lead or work with others on equal footing, and we will miss this bus too. Now, why there's so much push for 2D, worldwide, and I'll show you some slides later on, is because the capability that the 2D offer. I mean, not only it can replace silicon, but it can enable many other functionalities. For example, heterogeneous integration, which is, also in the industry roadmap going forward, right? It enables the kind of heterogeneous integration and integration of classical and classical quantum, uh, which is there in the industry roadmap, right? So there's already a lot of industry push. You would have seen many of you would have seen a lot of reports from industry. Companies like Intel and TSMC are reporting their progress on 2D semiconductors. And even worldwide, a lot of investment has happened on 2D semiconductors in of the scale of more than $1 billion in setting up many centers, many several startups, or even facilities which are now catering to industries such as, for example, IMEC. There are also several startups which have come in the 2D semiconductor domain, with, for example, companies getting funding of the scale of $100 million and £100 million. So the fact is that 2D semiconductor is a technology that India can encash, right? Uh, Today, the leading players are open to engage with us, but once the technology is matured, this engagement or this exchange is going to be very difficult. And once it is matured in other nations, we will be forced to be deprived for it forever, like what we see in silicon and other key technologies, right? So this was basically one such example of how jumping the roadmap, investing on the next generation technology, building our own IPs and processes will allow us to develop a leadership in future. Now let me talk about the proposal that we made some time back and India Semiconductor Mission, and also the gaps that we are required to be addressed and the opportunities that we have. So, one aspect that we said that India should not invest in bleeding edge. These are expensive and don't cater to market and also have very fast obsolescence rate. We basically said that one should invest in areas where there is low obsolescence rate, you need lesser investment, and also there are ample opportunities, enough market, or you can cater to the market directly. And that's how you start growing, right? So there are several areas. For example, you can get into automotive, analog, BiCMOS. In fact, the investments that you see now are pretty much into proposals in compound semiconductor, proposals in 65 nanometer and above kind of technology node, which are kind of low hanging fruit. Access to the market is easier compared to what a 28 nanometer or a 14 nanometer kind of a fab will look like, right? But again, this is something where we said that government has to step in and kickstart the process in a mission mode. Otherwise, we risk becoming a third world country in electronics as well. So our proposal was to go with a holistic approach. One need the right strategy, right? You need to invest on new ventures. It creates jobs. You need the right team, right policies, right strategies, and and we basically made a proposal that investment of a scale of $10 billion has to be made, which should have components such as R&D and manufacturing, and the R&D should cater to the manufacturing, and this manufacturing, the chip manufacturing, should cater to the larger electronic design and manufacturing ecosystem, which is more than $2 trillion kind of a market. So if we invest $10 billion, we can tap into the $2 trillion market opportunity. So let me give you an overview of India Semiconductor Mission, which was announced in December 2022, and resulting into all these announcements, fab announcements, and setups that we see today. So the ISM started with aim to build a robust semiconductor display manufacturing and OSAT ecosystem. There were schemes for three different kind of fabs: schemes for compound semiconductor, silicon photonics, sensor fabs, and OSAT facilities; scheme for semiconductor fabs such as silicon semiconductor fabs; and a scheme for display fabs. In the beginning, the fiscal support, the proportion were different depending on the technology node and the kind of fab it is. But later on, the government changed this to 50% fiscal support, along with a couple of state governments also announcing additional fiscal support. And the companies have to really talk about what technology they bring in, the finances, the operational details, the market assessment, environmental clearance. So there are a lot of detailing which goes in the proposals that the companies have to submit, and based on that the assessment happens. So thanks to all the process, we have some announcements happening now. Now, it's also important to see that what gaps are there and how, what additional aspects that government has to cater to if we want to become a leader, in manufacturing and R&D. So, couple of things which I could identify. For example, still we need a greater emphasis on R&D and D and innovation, and we need to develop, capabilities, R&D capabilities within India. We need a lot of support for skill development and technical education in semiconductor field. The kind of supply that we have, even all academic institutions put together do not supply enough people that can cater to even one single fab in the country. And the country wants to have dozens of fab in next few years. We also need, policies to build stronger supply chain. Just having fab is not good enough. On one hand, you need to have a lot of electronics manufacturers, local electronics manufacturers, and I'll stress a little bit on that. So from electronics manufacturing, I'm not talking about electronics integration or PCB fabrication in the country. I'm talking about design to manufacturing in the country. So if the design happens, the electronics design happens in the country, then these electronics manufacturer will set the requirement that, okay, we need this kind of chips, and then they can go to local suppliers and the design houses that we need this kind of chips, and these are the specifications, and then that can be designed and developed in our local fabs, and basically will feed it back to these electronics manufacturers. So we need electronics manufacturers in more and more electronic manufacturing in the country, where they also have their design houses in the country. So we need the complete supply chain at the electronic manufacturing front. At the same time, we also need enough raw material development and many other developments which feed to the fab, to be taken care in the country. We also need policies and efforts to increase collaboration between industry, academia, and also government, to kind of foster a conductive ecosystem. At present, there's a very limited focus on kind of an entire value chain, and especially if we are talking about local demand for chip, that entire semiconductor value chain need to have a greater focus. Also, we need, for example, in all these fab efforts, we need guidelines on technology upgradation. I mean, India cannot depend on technology licensing forever. So, for example, once we have licensed a certain technology and we have started manufacturing, we should have local effort to upgrade the technology further so that we don't have to depend on those technology providers in future. We also need incentives or policies for SMEs and startups in semiconductor sectors. Semiconductor is a capital intensive game, and if the government is not supporting startups, and I'll talk about this a little later, if government is not supporting startups, it's going to be very difficult for startups to grow, particularly deep tech startups to grow in the semiconductor sector. We also need robust policy framework to attract foreign investments in our country, and also, dedicated platform for facilitating international partnerships and collaborations. At present, it's very difficult to develop an international collaboration, and there are very limited schemes and policies under which the collaboration can happen, and things are not that efficient. So that has to improve significantly. Now, let me focus on some key aspects out of the gap that I identified, right, before I conclude. So, for example, deep tech startups. I mean, deep tech startups need funding, and particularly in the semiconductor sector, you need funding in the tune of tens to hundreds of $1 million, depending on how capital intensive your development is. Now, the majority of the seasoned VCs and investors in our country, they don't want to invest more than a couple of $1 million. So then it's very difficult for these startups who are thinking big, planning big, to basically get into this kind of a sector which is capital intensive and funding intensive. It's also important to highlight that majority of the VCs and investors, I'm not talking about all of them, but many of them either don't understand the technology, or they would expect the return on investment in say about 2 to 3 years. Now, this is also kind of detrimental to semiconductor startups because semiconductor takes a longer time before a return on the investment can happen. But on the other hand, if you see the situation of the mindset in other countries such as US and Europe, the deep tech startups, have easily, raised fundings of the scale of 150 to $100 million, even more. For example, in GAN, many startups have raised funding, of the tune of, several $100 million. In 2D, for example, I was talking about some of these startups. They have raised, funding of the scale of 50 to 100 million pounds or dollars, right? And that kind of mindset at present doesn't exist, and that has to change. Now, this will take its own time. I mean, India cannot wait for private investors to become risk taker. This will take its own time. And in this case, government must pitch in with policies to support startups by playing investors' role. At present, government gives funds or grants or loans, but government doesn't pitch in as an investor. If government pitches in as an investor against equity and government invests as against equity, can also come up with policies to encourage private investors and VCs to invest in high risk and high demand projects. You will see more and more capital intensive startups coming in our ecosystem, which will further load these fabs in future and help upgrading these fabs in future. The second aspect is skill development and manpower development, and technical education. So, I mean, here we need to be thoughtful. We need to put some thoughtful efforts on skill development. A significant effort in upskilling is required. We all know that majority of the undergraduates at present are not skilled, or skilled in a sense that the industry would like to have all of them, right? So we need to be thoughtful. The semiconductor development, semiconductor manufacturing is a lot more skill intensive, a lot more complex than, for example, electronics manufacturing. So you need greater level of sophistication in the skill that is needed. Many of the master's program in India focus only on chip design, but semiconductor fabs require workforce with, for example, device design, test characterization, modeling, process engineering kind of training. This is largely missing in our country. BTechs in VLSI won't serve the purpose. There are also some proposals that we'll start BTech in VLSI or VLSI design programs at BTech level. This won't serve the purpose. This will only increase the number of VLSI designers in the country, but not people who have device design, test characterization, modeling, process engineering kind of expertise, which requires a master's level training. Also, on-campus MTech programs with 20-30 seats won't fulfill the need. Even if you put all MTech programs across the country, across all institutions, it doesn't cater to single fab requirements. So for that, one has to think of larger programs. In IISc, we started some of these online mode programs which can cater to the mass. And government really need to collaborate with local experts. I mean, government is trying to build international collaborations, but international collaboration don't help in local skilling needs. So government really need to collaborate with local experts and local institutions, IITs and ISCs and so on, right, to build this kind of skill that is needed for some of these fabs. And this has to happen at speed. Now, the last aspect is industry academia engagement, and I kept this towards the end because I also wanted to ask this question: that is Indian academia working on the right problems in semiconductors? Now, let me elaborate this question. So if you see most of the technological advancements, which have happened through academia or through academic innovations, through a professor, is usually when a professor has worked on a problem that was something on which industry was struggling with. Whether we talk about, a VLSI innovation, which led to all this, the technology which enables the kind of integration that we see today, or many other technologies happened because, the industry was struggling with something and somebody came up with a solution. So we need to basically build close ties with industry and look for problems which industry is struggling with, which can benefit industry in next 5-10 years, right? And for that, we need close ties with industry, between industry and academia. Now, this is missing in our country, though I see this reasonably present in other countries, right? Also, unfortunately, majority of the semiconductor industries in India, I'm talking about both local and MNCs, do not have vision beyond 2 years and appetite to fund R&D. So I don't see much of a R&D funding from semiconductor companies in India, except couple of them. For example, Samsung funded big time, to ISC. Intel has funded, but TI, but again from US has funded. But I'm talking about majority of the companies are not funding R&D in our academic ecosystem, and also they don't have problem statements beyond 2 years, which then doesn't become attractive or interesting for academia. So this also need to change, right? If India wants to lead through its own IPs and technology. Now, this is where the government has to pitch in and develop policies to encourage industries to invest in academic R&D and develop a long-term collaboration with academia. One way one can do is, this is one proposal I made was, can government match the funds? For example, if a faculty is able to raise X amount of funding from industry, can government encourage schemes, develop policies and schemes where faculty raise X amount of funding from industry under certain, deliverables, and the government gives, another X to build the facilities and whatnot. Industry mostly doesn't fund on capital. Industry doesn't fund on equipment. So say government can fund equipment, match that X amount of money and support the faculties. And if that kind of thing happen, this will encourage a lot of faculties to reach out to industries and pitch for funding. So, these were some of the way forwards I thought would be beneficial for our country. Now, towards the end, let me conclude. So finally, we have started a long-awaited run, or I would call it a marathon run, thanks to all the stakeholders. But, we have to remember that this is a marathon run, and we have a long way to go. And the way to go is we have to address these gaps. We have to focus on our R&D capabilities. We have to support startups. We have to build strong industry academia partnership. And also, we have to develop a mindset to jump the roadmap, which is very important. Risk-taking ability is very important. If we want to play a key role in making India leaders in semiconductor R&D as well as manufacturing. On this note, thank you very much to the audience. I hope I finished in time.
Thank you, Professor Mayank. Now over to IIT ISM Dhanbad.
I would like to thank Professor Srivastav on behalf of IIST and IIT ISM Dhanbad. The house is now open to any questions from our professors and researchers.